Okay, guys, 1.4 is not by far your favorite lesson, maybe. This is the one where we just rearrange equations that either just have letters or letters and numbers, but we're not solving, we're just rearrange them to solve for a certain letter without really getting a number as a result. The first problem we're going to look at, it says solve 7x minus 3y equals 8 for y. As soon as you hear for y, I need you to circle that and say this. I need to end up with, when you hear that, with something that's going to equal y equals something. I'm solving for y, which means, first of all, everything that does not have y has to move on the other side. This 7x does not have a y, correct? So we're going to go minus 7x minus 7x. And as a rule, I've told you even in Algebra 1, anytime we move an x over, please put it first. We're not going to let this be 8 minus 7x, but we're going to write this as negative 3y equals negative 7x plus 8. Whatever has x comes first. And this is going to be very helpful when we do slope, when we do the slope-intercept. Just remember, everything that has x comes first. And then I just need y equals. I'm going to keep circling what I'm solving for. I have a number in front of it. I need to get rid of it. Divide by negative 3 on all of them. This goes away. I end up with y alone. That's what I needed. And negative divided by a negative becomes a positive. A positive divided by a negative becomes a negative. It's 7 over 3x minus 8 over 3. And we are done. The only thing you need to do is solve for y, which means that translates to y equals something. We don't actually have to have a number at the end of this, right? Same thing with example 2. They want the exact same thing for you. They say solve this for y. So we said we're going to circle y. We want y alone. Well, first thing is going to go is that the thing that doesn't have any y, which is this x. Minus x minus x. End up with x, y equals, as a rule again, negative x plus 1. The book doesn't do it that way. We are going to do it this way all the time, all the time, all the time. And then I'm solving for y. I'm going to go ahead and circle it again because now I see, oh, I have an x. I need to get rid of it. The operation in between is a multiplication. I'm going to divide. I'm going to divide y equals negative x plus 1 over x. And I have my answer. The book has it 1 minus x. I couldn't care less. I always want you to write the x first because in the long run it's going to be very, very helpful to you. So let's go ahead and do it that way. Once we did this, it says go ahead and evaluate when x is negative 1 and when x is 3. Well, if x is negative 1, y becomes negative negative 1 plus 1 over negative 1. A negative negative becomes a positive. 1 plus 1, 2 over negative 1 or negative 2. When y is 3, that's what we're looking for, right? Yes, this becomes negative 3 plus 1 over over just 3. Sorry, I messed up. Negative 3 plus 1 gives me a negative 2 over 3. And those are the two values. Once we know what we're looking for, we just plug it in for x and get our answers. Now things are going to become a little bit more complicated in the word problem, but not very. As long as we can write this correctly as a verbal model, everything else will work out, okay? Let's look at example 3 on page 27, and we're just going to go ahead and try to figure that one out. It says, you're organizing a benefit concert. You plan on having only 2 types of tickets, adult and children. Write an equation with more than one variable that represents the revenue from the concert. How many variables are in your equation? Well, first of all, revenue means how much money you make. Okay, so we're thinking total revenue. How do we make money with this concert? Well, first of all, it's going to be by monies per adult times number of adults, right? Plus monies per kids times number of kids. The way we make money is by selling tickets to adults for a certain price and then selling tickets to kids for a different size. We're going to have to give all of them a variable. So I'm going to name this R equals price per adult. What do they call it? I want to see. Okay, they just use P1. I'm going to use P1 per adult times number of adults times A plus P2 for price for the kids times C from children, right? So the way I make money or my revenue is the price per adult times number of adults plus the price of children times number of children. If you look at this, I have 1, 2, 3, 4, 5. 5 variables, right? This is how you write it down. Believe it or not, example 4 is a continuation on example this, because now they're giving you some stuff that you need to know. It says, for the constant in example 3, we just worked right here, your goal is to sell $25,000 in tickets. You plan to charge $25 per adult and expect to sell 800 adult tickets. You need to determine what to charge for children ticket. How much should you charge per child if you want to sell 200 children tickets, 300 children tickets, or 400 children tickets? Really what they want you to do first is to isolate the variable for this, for the price for children, right? So what we want to do is have this alone. Because your question is, how much should you charge per child? So we're going to do the exact same thing we've done before. We want to move stuff around to where we end up with P2 equals something. First that needs to go is this one, right? And it moves together. It's going to be minus P1 times A minus P1 times A. So I end up with R minus P1 times A equals, this is gone, P2 times C, because I moved the other one. And I just want P2. I'm going to continue to circle it because it's still not alone. I need to divide by C to get rid of it, which means my P2 is going to be my total revenue minus the price 1 times the number of adults that come divided by the number of children that come, right? Well, now that I have this formula, I can play with it based on what they ask us. They say, how much should you charge per child if you want to sell 200 tickets for children? So let's go ahead and do this. P2 would equal my total revenue. They already told us we're going to sell $25,000 minus the price per adult, which is 25.25, times the 800 adults that are coming. If I didn't make this one up, okay? And now I go, well, what if I want 200 kids? What will that be? This is a horrid thing. We're going to plug it on the calculator. We did it in class 2. You know how to do this. This ends up being $24. You're just going to go this minus this times this in one move in a calculator, and then you're going to divide it by 200, and you're going to get $24 per ticket. Well, what if we want to have 300? P2 would equal the exact same thing. I'm not going to rewrite it, but divided by 300, right? It's the same top, but this number changes, which this gives us $16 per ticket. If we get $300 kids to come in, then we only have to charge $1,600. And then again, for the last one, for P3, is the exact same thing on the top by divided by 400, right? It's the exact same top, but now we're having 400 kids coming in, which this would come up to $12. I'm just lazy. This would be written here and this would be written here. It's the same amount, right? Because this formula never changes. The only thing that changes is the number of kids that would come to this concert. But what really makes sense in here is to understand what we're looking for, which would be this number. It would have been also just as easily to plug everything in and calculate separately. We could have put the R, the P1, the A, the C, and then keep doing the math on it. But if you just isolate it here, all you have to do is plug all of the numbers and do the math. As we flip to page 28, you have that cheat sheet that I already gave you. You should have it with you. And it has all kind of formulas there. Preferably by the end of this math class, as in the year, all of these should be completely memorized, okay? Example 5 and example 6 are just writing or rewriting common formulas. You have the perimeter of rectangle is 2L plus 2W's, and they want you to solve for W. Same thing, we're going to just circle it. Anything that doesn't have W has to move. The first one is going to be the 2L, right? It doesn't have a W in it completely. This becomes P minus 2L equals 2W. We're solving for W. It still has a number in front of it. That's why I circle it. The only time I stop circling it if it's just alone, right? So I divide by 2. And I end up with W. I don't have to circle it. It's P minus 2L all divided by 2, right? And we rewrote it. In the same way, they say they have a example 6, a word problem. Let's do the area of a rectangle. Area of a rectangle on your cheat sheet is length times width. Let's go ahead and read the problem. It says you have 40 feet of fencing with which to enclose a rectangular garden. Express the garden area in terms of its length only. The two problems are related or entangled, and here's why. You want area to equal something only with L in it, right? Well, let's look at this really, really fast. W shouldn't be there, but I already defined W right here. We said that within a rectangle, the width of a rectangle will be the perimeter minus 2L divided by 2. So I can rewrite this as area equals length times perimeter minus 2L all over 2, correct? Instead of W, I can replace it with what I just defined it in the previous example. Now that I have that, I know what perimeter is because it tells me at the beginning of my problem, I have 40 feet of fencing. So my perimeter is 40, right? Area equals length times 40 minus 2L divided by 2. And believe it or not, this can be reduced a little bit, right? A equals length times, what's 4 divided by 2? 20. Minus what's 2L divided by 2? 1L or L. And now you have your area only in terms of length, and there's no W there. All we had to do is replace the width with what we found it in here, then do a little bit of math, and it comes to only length as a formula. These tend to be complicated. We're not going to worry about it. We're going to work them in class more if we need to work them in class more. Out of all of these, this is what I think will give you most of a headache, but hopefully it will work out. Good luck with your homework.